All right, so here's your free response question of the day. This is the actual question that was used in 2017, question number 3 for number 2017. So in this question, you're given a graph, and it's important to remember what the graph describes. It's the derivative of f that you're looking at. It says it's differentiable on that closed interval and satisfies this, that f at -2 equals 7. So you're given a value of the actual function. The graph of the derivatives there, and it consists of a semicircle with 3 line segments that you're seeing, and then you have to do certain things with the information given. So the first one is, can you find what f at -6 equals? So for that one, we have to go back to what we know. So we know f at -2 equals 7. So we're going to start there at 7. Then what we're going to do is we're going to integrate. Now, I'm going to integrate the derivative to know whether it increased or decreased. So we know -2, but we're going to go -2 to -6. Now I want you to notice that the bounds are flipped a bit. Usually the lower number, the minimum number, is at the bottom of the bound and the greater one's at the top of the bound. Now we're still going to find area under the curve. It's just that when we do it, it's not going to be positive or negative. We're going to change the sign of the answer to that. So let's look at that really quick. So from -2 to -6. So here is -6. Here is -2. So it's a triangle. So I can see it's 1, 2, 3, 4, half the base times the height. So I can see the triangle's 4, the area of that. So half the base times the height. The area of this is 4, but I'm not going to write that as a positive area, even though it's above the axes. Because we're working backwards, we have to do the opposite number for that for the area, so it would be negative. So it's 7 and -4. So if we work backwards, that means f at -6 equals +3. Now I'm going to do the next one down here. So the next one is, could you find at 5? This is more traditional maybe as such. So for 5, again, we're going to start with 7, and then we're going to integrate -2. But from -2, we're going to go to 5. Now notice for this one, when we do the integration, the lower number is on the bottom and the greater one's on top. So we don't need to do any flippity-flip. Just what the area is, you're going to add to this. So from -2 to 5, can you tell me the area? So from -2 to 5, first of all, I have a semicircle here. I also notice it's below, so it's a negative area. So the area of a circle is pi r squared, but I have to divide it by 2 because it's a semicircle. What's the radius of this? And you can tell the radius is 2. So we plug that in. But because it's below, it's going to be a negative area. Now we're going to add to that negative area what's above. And what's above, again, is a triangle. Now, what's the base of this triangle? 1, 2, 3. And then what's the height of it? 2. So half the base times the height. You could also go half the height times the base, and you get the answer 3. So half of 2, that's 1, times 3. You don't have to worry about fractions then. So the area of that is 3 for that triangle. And again, it's positive because it's above the axes. And then put that together. So if I put that together, 7 plus 3 is 10. And then 4 divided by 2 is -2 pi. So it's 10 subtract 2 pi. And you did it. So there's 3a, and you found the value of both, starting with a value given. B. On what intervals is f increasing, and then justify your answer. So where is the function increasing? So you're given the derivative. So it's increasing when it's positive, the derivative. And where is it positive? In what intervals? It's where it's above the axes is where it's positive. So from -6 to 2, -2, and from, what is that, 2 to 5, on those intervals, f at x is increasing because the derivative is positive or greater than 0 in those intervals. So why did you pick that answer from -6 to -2 or 2 to 5? It's because the derivative is greater than 0 in those intervals. Done. 3C. This one's going to require another piece of paper. So I'm going over here. So again, this is 2017, the FRQ question number 3. So for this one, for C, it asks for what's the absolute minimum? That's my goal. So to find absolute minimum, I'm going to do a table of values. And I need to know the values I'm looking for to find absolute minimum. So the first thing I'm looking at when I do that is I'm looking for the x-coordinate of the endpoint. So for this one, from -6 to 5, -6 and 5, those are the end values. So you start there. And then I need to find the critical values. Now the critical values is when the derivative is equal to 0 or doesn't exist. Now, it does exist everywhere because it's continuous, the derivative. So I'm just looking for when it's equal to 0. So I already have the end values, so the other numbers that need to know when they're equal to 0 are -2 and +2. So first of all, those are the x values I'm looking at. Those are called the critical numbers. And then I want to find what the value of the function is at those numbers, and then whatever the lowest value is my answer. So at -6, we just did that in part A. So at -6, the answer was, what was it? There it is, 3. We did that in part A. At 5, we also did that in part A, and we said that answer was 10 subtract 2 pi. Now, if you ever want to know how to estimate what this value is, pi is pretty close to 3, rather than 3.14 if you didn't have a calculator. So this is like close to 10 take away 6. So already this answer is bigger than this. So 3 still is my absolute minimum. Now there's 2 I haven't found yet. And so one is at -2. Well, that's given in the question. It says f at -2 is 7. And there's one I still need to find that I haven't found. And that's at +2. So let's find that right now. So to find that, we'll do what we did in part A. So start with the information given, which is 7. And then I'm going to integrate from -2 to 2. And then find that answer. So I need to look off the graph from -2 to +2. Well, from -2 to +2 is a semicircle again. So just the area of that, and it's negative. So it'd be 7 subtract, because it's negative, pi r squared divided by 2. So that answer is 7 subtract 4 divided by 2, 2 pi. Remember I said a good estimate for pi is 3? So this would be like 7 take away 6. So approximately that answer is pretty close to 1. So which one of these give me the absolute minimum? And when they ask for absolute minimum, they're not asking for the x-coordinate, but what the actual value is of that function. So which one gives me the smallest answer? And you can see it's this last one right here. So the absolute minimum from -6 to 5 of f of x is 7 subtract 2 pi. And your justification is your table of values. In your table of values, you show that you did the endpoints and the critical numbers, and you solved for each one, and that's how you came up with your answer. There's not another explanation in words that you would need to put on top of that. All right, last one, 3D. Says for each of this, can you find the second derivative at -5 and the second derivative at 3? And if you can't, say why not. So how would you find the second derivative if you're looking at the first derivative? So if I want to find, this is the first derivative, so the next derivative looking off the graph is to find the slope. So at -5, it's in the middle of a sloped line. So whatever the slope of that line is the derivative for all the x values connected to that line. So what is the slope of this line? Rise over 1, well, it's negative, so we went down 2 and to the right 4. And that's a great answer. You don't have to simplify it. So it's just the slope of the line. How about at 3? Well, at 3, which is right here, what's the derivative there? And I want you to notice that at this point we have a corner. And so this does not exist. But why does it not exist? And we can say there's a corner or sharp turn. There is a way to describe this as a limit too, that you could describe the limit from the left. And when you're looking for the limit, you're just looking for the slope, right? And one way to describe the slope is this. Does not equal the limit from the right. So there's a limit explanation of why that's a way to describe a corner. So from the left and from the right, they don't equal. This is a fancy way to talk about a derivative, right? This is using the slope formula with a limit, like from first principle, to describe the left doesn't equal the right, and that's the reason the slope or the derivative does not exist when x equals 3. All right, Mr. G Math, over and out. I'm proud of you, as always, for doing your work. Till next time.